This goes on page 29 when we're done. Okay, so we are reviewing dividing polynomials. There's two different ways that you've learned. You learned long division and you learned synthetic division. And some people seem to like synthetic division better. That's great, but most of the time, most of you would need to be reminded what those rules are, and that doesn't do you any good because then that means you don't really know how to do it. Plus, synthetic division doesn't work for everything, for all of our polynomials, which long division does. Okay, it'll work for number 4, and synthetic division for number 5, I'd have to force it into synthetic division with fractions, and then it gets real yucky. And if you had pre-AP Algebra 2 last year, you probably did some of those, but they're no fun, and we don't want to have to do it that way. Synthetic division would not work for number 6 because we have an x squared in it. So plus College Board's expectation really is the long division side of it anyway. So we're just going to do one way because it works for everything we need. But before we get that far, we are going to go back and look at something we learned in elementary school with long division. So let's do this so I can show you how it's literally the exact same thing for the most part. Okay. So we're taking 13, dividing it into 5,467. I hope so. And so we would take 13, and I don't try and divide 13 into the whole thing, right? I just divide it into the first part, 54. How many times does 13 go into 54? Evenly, 4 times. So then 4 times 13 is 52. Then what do I do with those? Subtract. Okay, so the way I want you to think about it, that's not wrong, okay? But the way I want you to think about it is that, yeah, we're subtracting, so that means we're going to change the sign on the second row. Okay, so you're going to say that to yourself multiple times here. So then I combine them, and I get 2 here, and I bring down the 6. How many times does 13 go into 26? 2. 2 times 13 is 26. Then I change the sign on the second row, right? Then these zero out. Does that mean my answer is 42? No. Okay. I have to bring down the 7. How many times does 13 go into 7? 0. Okay. So, and then you have a remainder. So when you very first do long division, you probably wrote remainder 7 or little r7, and then you got a little past that. So my answer here really is 420, and then the remainder, which is 7 over 13. And there's your mixed number there. Okay. That sound familiar? We good on that? Okay. So now let's take those exact same steps and make them into polynomial stuff without making things harder than they need to be just because they look ridiculously hard. So we're going to take x plus 4, and we're going to divide it into 3x cubed plus 2x squared minus 37x plus 12. Okay? What did I do? Yeah, okay. It's okay. Sometimes I write things wrong and say things wrong. All right, so just like over here I had 1 term. Over here I have 2 terms, but I'm only going to take the first term. So technically over here I took the first term because there was only 1. And I divided it into the first part. So I'm going to divide that into this first part right here. Now, when you first learn this, some teachers tell you to take that term and write it off to the side and put 3x cubed and divide it by x to figure out what you get. That is totally fine. And if you need to do that, that's fine. I'm not going to do all that because we should really kind of be past that. So 3x cubed divided by x is going to give me what? 3x squared. Okay, so then I make sure I put it above my x squared term. Okay, where you line this stuff up is very important for it to make sense to you and things to work out for you. Okay, so then I multiply it back. 3x squared times x is 3x cubed. 3x squared times 4, 12x squared. Okay, then I change the signs on the second row. Change the signs on the second row. Okay, because sometimes they're negative. What did I do? Oh, because it's 3, okay. 3x squared times 4. I'm sorry. 3x squared times x is 3x cubed. Then I do have to multiply 3x squared times 4. That gives me 12x squared. Okay? Okay. Everybody with me now? Okay, and the reason we say that we're going to change the signs on the second row is because sometimes those signs can be negative. So we don't want to just think about it as subtraction. We're going to get things all weird. So we just change the signs. It's like subtracting everything, right? All right, so then these will zero out. And then I have a positive 2x squared, negative 12x squared. So that's a negative 10x squared. Then I bring down my negative 37, just like I negative 37x, just like I brought down the 6 over here. Then I do the same thing again. Negative 10x squared divided by x gives me what? Negative 10x. Just a plain old x, right? Because one of the x's goes away. Then I multiply it back. 10x times x. I'm sorry, negative 10x. It would be negative 10x squared. Negative 10x times 4. Negative 40x. Then what do I do? Change the signs. Change the signs on the second row. These zero out. Negative 37, positive 40 gives me a positive 3x. Bring down my 12. Make sure you bring the signs down with the numbers, whether it's positive or negative, because when you don't do that, sometimes you start to confuse yourself, okay? Then we do it again. 3x divided by x is a positive 3. Then 3x plus 12. And what do I do? Change the signs. And then those zero out, and we're done. We don't have a remainder on this one. Okay, so then my answer is 3x squared minus 10x plus 3. So we do this to be able to reduce a polynomial. Maybe it's because we had a 4-termed cubic right there that we couldn't factor by grouping. And if we know one of the factors, we can divide it out so we could get down to this to then maybe be able to factor this or solve it some other way. But if I take this and I multiply it by this, I should get that back. Okay, I'm not going to do that to check myself, but that's basically what we're doing. We're unmultiplying. 29? 29, yes, 29. All right, everybody good so far? Okay, so let's do another very straightforward one just to make sure we're all on the right track here. So 2x plus 7 on the outside. On the inside, we've got 2x cubed plus 5x squared minus 19x minus 42. Okay. And always be careful when if you're having to rewrite it to write it down correctly. Alrighty, so 2x cubed divided by 2x is x to the second. Good, just x squared, okay? Then I multiply it back. X squared times 2x, 2x cubed. X squared times 7, positive 7x squared. Then what do I do? Flip the signs. Okay, those zero out. 5x squared minus 7x squared, negative 2x squared. Good. Bring down my negative 19x. Then do it all over again. Okay. Negative 2x squared divided by 2x is what? Negative x. Okay. So I multiply that back. I get negative 2x squared minus 7x. Then I flip the sign, change the signs. These zero out. This gives me what? Negative 12. You're trying to cheat me out of the money you owe me. And then minus 42. Negative 12x divided by 2x, negative 6. So then this is negative 12x minus 42. Then I change the signs. Everything zeroes out. And I get x squared minus x minus 6. Okay. Okay, Priscilla, you're good. Now, will I always have a remainder of 0? No. And we'll look at one of those in just a minute. But before we do that, we're going to do one where we have an x squared on the outside. Does it make it any more difficult? Steps are exactly the same. In this particular case, something happens in the middle that I want to make sure we address. So let's go ahead and do this. X squared plus 8 is going to divide into x to the 4th plus 3x cubed plus 4x squared plus 24x minus 32. Okay. All right, so x to the 4th divided by x squared leaves me with x squared. And I put it above the x squared term. Okay, make sure you line things up correctly. Otherwise, again, you just start to confuse yourself. We multiply it back. X squared times x squared is x to the 4th. And then x squared times 8 is a positive 8x squared. I put it underneath the x squared term. Line them up correctly so you don't start making up math. All right. And then it's okay that I have a big gap there. Totally fine. I changed the signs on what I have. These are going to zero out. This is basically like 3x cubed plus 0. So we're really just bringing this down. 3x cubed. And then negative 4x squared and negative 8x squared gives me a negative 4x squared. And then I still have to bring down that 24x. Okay. Everybody with me so far? Any questions about anything, where it came from, whatever? Okay. All right, so then 3x cubed divided by x squared gives me 3x. Multiply it back. 3x cubed plus 24x. OMG. This phone, I swear. I'm going to unplug it. 24x. You can keep going. Oop. All right, we back. So then I'm going to change the signs. Hopefully, maybe you finished. That would be good too. And oops, I'm going to zero that out. This comes down. I get negative 4x squared. Those zero out also. Bring down that negative 32. Divide that. I get minus 4. Negative 4x squared minus 32. Change my signs. Those zero out. Those zero out. And then my answer is x squared plus 3x minus 4. Okay. We all good on that? Yes? Any questions at all? All right. Flip it over. We're going to do number 7. So x plus 1 goes into 3x cubed plus 7x squared plus 2x minus 7. Okay. Now we're doing this one because we're going to get a remainder on this one, and we got to make sure we know what to do with it. But the rest, I mean, you don't know that when you start, so you just start like you start anything. 3x cubed divided by x. 3x squared. Yeah, that. Yeah, that. All right, multiply it back. I get 3x cubed plus 3x squared. Change the signs. Those zero out. This gives me 4x squared. Bring down the 2x. 4x squared divided by x. 4x. 4x squared plus 4x. Then what do? Change the signs. Negative 2x, bless you. Bring down the negative 7. Uh-oh. Negative 2x divided by x gives me what? Negative 2. Multiply it back. Negative 2x minus 2. Especially on the last step, make sure you change the signs. This is where y'all usually get really sloppy because you're like, oh, I know what's going to happen or whatever. I don't know what you're thinking, but this gives me a negative 5. Okay, so I did not get a 0 here. That is your remainder, yes. So I want you to think about a fraction like 1.5. All right, and I've got this recipe, and I'm going to use 1.5 cups of flour. So I put in 1 cup, and then I add another 1/2 cup, right? So even though we say 1.5, which really means 1 plus 1/2, right? Like we don't say it that way, we don't write it that way, but that's what 1.5 means, right? 1 plus 1/2. And so when it's a polynomial, that's basically what we have to write. What we got plus what our remainder is. So when I write this out, I'm going to have what I ended up with up there, 3x squared plus 4x minus 2, then plus, I don't care if your remainder is positive or negative. Okay, I'll explain why in just a second. Just like here, you're adding the remainder. Your remainder is -5, and that's over x plus 1. Okay. Now, if I had written this as minus and put a +5 up there, I would have been totally fine here. But if that was -x or -5 minus x or something like that, and I just put the negative out front, I would be totally wrong. And so to avoid, and you may not even understand why, but just to avoid that, think about it just like this. You always add it. If it's negative, you make it negative up there. It's fine. But don't do it on the adding and subtracting part. Okay? We good? It's just like a safety thing, really. All right. So 8 works out just like that. I don't think we need to do it. We're also going to skip 9 because it works out just like the rest. It looks horrible, but it's actually shorter than some of the other ones. They all just work out the same if you know what you're doing. So we're going to go to number 10.
Missing powers.
Missing powers, yes.
Oh, no.
Here's where else you get yourself in trouble. When a power is missing in a dividend, that means what's inside the house. You have to use a 0 to fill in the missing term. You absolutely have to, or it ain't going to work out. The good news is that if you're actually lining things up and you know what you're doing, if you forget it, you should catch yourself because things won't work out right, and you'll know that before you end. So what I mean by a missing term is I have this x to the 4th, then it jumps to x squared. I'm missing the x cubed term, okay? I can be missing terms on the divisor. That's fine. Like on the other side, I think we had x squared plus 8, and we didn't have an x term. Totally fine if it's on the outside. If it's on the inside, nothing can be missing. So out here, we have x minus 8. Give myself some more room. X minus 8. On the inside, I start with x to the 4th. There is no x cubed term, so I'm going to put plus 0x cubed. I need a placeholder there. Then I do have an x squared term, minus 64x squared plus 9x minus 80. So you have to have every term accounted for. That includes your constant term. Okay, the one at the end that doesn't have an x on it, it would need a placeholder like 0 as well if it was missing. All right, so now that we have that, we just work it out like the rest. So x to the 4th divided by x, x cubed. And see if we're lining things up, and if we forgot that 0 term, we should be able to catch it right now because I have nowhere to put that, right? Unless you just, again, are not paying attention to what you're doing. Multiply it back, I get x to the 4th minus 8x cubed. I change the signs. Those 0 out. 8x cubed. Bring down the neg 64x squared. Okay. 8x cubed divided by x, 8x squared. Good. Positive 8x squared. Don't forget to put the signs on the top as well. Multiply it back. That gives me 8x cubed minus 64x squared. Then I change the signs. And those 0 out and those 0 out. Completely zeroed out, which is fine. That can happen. That does not mean that I'm done. Okay? Just like when it's zeroed out on the front up there. So, but when that happens in here, not only do you bring down the next term, but you have to bring down a second one as well, because you're basically skipping over something. And the 0 is just, I mean, we can put plus, we just kind of ignore it. It doesn't matter that it's there. Okay. Then 9x divided by x is a positive 9, and I put it above the constant term. So I have a gap in the top. Totally fine. So my answer is going to be missing an x term. Totally fine. Okay. That's why we line it up so we don't get confused at the end that we think we got to keep going. Multiply it back. I'm going to get 9x minus 72. Change the signs. And then I get -8 right there. Okay. So then my answer is x cubed plus 8x squared plus 9. I don't have to have a placeholder in my answer because that would look ridiculous. I mean, you could, it's not wrong, but you're not going to see it that way. And then plus my remainder, which is a negative 8 over x minus 8. Okay. Can I cancel those 8s out? No. 100% no, exactly, because I have addition or subtraction. If it was multiplication, if it was negative 8 over negative 8x, then yes, but no. With more than one term, no. And no, just no. Okay, we good? All right, then I want you to work on 11 while I hand out your assignment, and then I will work through it. Yelled at you for what?
Dividing the top with x at the bottom.
Ah.
It has to go over test.
Okay, see, but now do you know not to do that? Because Archer yelled at you so much.
She threw papers at me.
All right. Did it work? Am I going to have to throw paper at you as well? Your shirt is completely inappropriate for school, just so you know. I'm not going to send you down. Just don't wear it again. It says tequila on the back. Can you believe her? Why? How are you even friends with her? No. Not me. No, where are we supposed to? Where are you supposed to go? Okay. Oh yeah. I'm sorry. I was trying to figure out what. Yeah, 116. She's right across the hall. Uh-huh. All right. Did I miss anybody with the assignment? Every table I got some. Okay. Sometimes I walk around in circles and. All right. All right. So I will work this one out for you. Do what? Because we are it's matching day. It's like twin. It's like I think we call it twin day. That's today. It's today. I know. Crayon. Are you not from around here? Are your parents not from around here? Where's she from? Up north? Yeah. Crayon. Crayon? Crayon? Okay. Hey, you're in Texas. It's crayon. Crayon. If y'all missed Mr. Ackerman, he's a crayon sharpener. Did y'all see him sharpening himself? Coach Havner made it. We made it. I brought a box and she made him a thing, and so he's in it, and it's got like this big thing with the sharpening. And he doesn't have any armholes, so I'll hold the box and he spins around, and it looks like he's sharpening himself. It's funny. All right, check yourself with me. And if you ever wondered what I meant by the class videos are not, they're not like award winning and random things. So if somebody's watching this video, they heard our whole crayon conversation and our sharpener, like it's just in there. I ain't got time to edit it, and I don't care. Nah, it's fine. I don't have time for all that. Do y'all agree with my answer? Am I right? Yeah, right. Okay. We good? Yes?